So, hello and welcome to another video from sickmaths.co.uk. There it is, that's what it says. Where you can find the whole of GCSE Maths explained on video, all for free. So, this video is about volumes and surface areas of different shapes. First of all, there's one group called Prisms, so not one particular shape, but a kind of shape. Okay, and then you got cones on the other side, and spheres, and even hemispheres, which is simply half one of those. Okay, so let's start with prisms. Prisms are basically something that is the same all the way through. So this shape, this cuboid, is a rectangle all the way through. This cylinder is a circle all the way through. And that shape, which it is it's the same all the way through, is called the cross section. So wherever you slice this, you get a nice rectangle, or wherever you slice this, you'll get a circle shape, and that is called the cross section. So we want to know the volume and surface area of these shapes. So let's talk about the volume of prisms generally. No, actually, we'll start with the volume of a cuboid and cylinder, and then we talk about volume of prisms generally. So, let's work out the volume of this loaf of bread, which is in the shape of a cuboid. What you do is you work out the volume of the first slice, so that's 2 cubes by 3 cubes, so altogether you've got 6 cubes, and it's actually 1 cube thick, so it actually really is 6 cubes. There's 1, 2, 3, 4, 5, 6 full cubes, okay, 1 centimeter, or 1 unit deep, okay. Now imagine this loaf of bread is made out of 10 slices, so you worked out the volume of the first slice, which is 6 cubes, so the volume of 10 slices would be 6 cubes times 10, which is 60 cubes. So all I've done to work out the volume of the whole loaf of bread is the height times the width to get the first slice, and then times the depth to multiply by how many slices there are. So really I've done height times width times depth, which is the volume of any cuboid. Okay, so that's the explanation and how you come to this formula. Okay, let's talk about the surface area very quickly. This has got 6 surfaces, a front and a back, a side and another side over there, and a bottom and a top. Okay, now if you open it up, you get a net shape like this. So a net shape is basically this shape, and when you fold it up, it becomes your 3D cuboid. Okay, so this is supposed to be flat, if you can't imagine it. And so this bit here, just for your own reference, is this front shaded bit here, which has got height times width, height and width, okay? And then its depth is how long this is. And you can imagine, this is this side over here, this wraps on top of that, and is the top there. This on the bottom of the cuboid, and this is wrapping to the other side, and this, which is the same size as that, is on the back over there. Okay, so that's your net of this shape. And if we wanted to work out the surface area of this, which means the surface area means all the surfaces, areas of them added up. So basically, let's work out the area of the front. It's height times width, and you've got 2 of them because you've got this shape is in the front and the back. So 2 times height times width, like I've written here. Then you've got a side, which is height times depth, twice, because you've got a height times depth over there. Now if you want to see that on the what's it called, the net, it's over here and there. That's this side is this one here, this side is that side there. So you got 2 height times depth, which I've written there, and of course you've got the bottom and the top. So the bottom is width times depth, and you do it twice, so it's 2 times width times depth. So you add all those 3 things up, and you get the total surface area of a cuboid. And for a cylinder, very similar when it comes to the volume, like any prism. Basically, you work out the area of the cross section, the bit that's the same all the way through. So in this case, you've got pi r squared. Okay, and let's imagine again it's made up. This time it's what do you call it? Pepperoni or something, or salami. And so you can cut it in lots of slices, and the first slice is 1 unit thick, so it's actually got a volume, okay? You do the area times 1 unit, that gives you the volume of 1 slice. And then if you've got 20 slices, you times it by 20. If you've got 15 slices, you times it by 15 slices, or whatever the depth is. So it's h units deep, or sometimes you call it the height when it's standing up. That's why it's called h as well. So you simply do pi r squared, the area, times how deep it is, and that gives you the volume, a bit like this one. Okay, now surface area, the SA, is basically, let's open this thing up. Basically, you've got a circle in the front and the back, like you can see here, and you've got this kind of wrapper, which wraps round the circle on both sides. So this comes in, this wraps round. Okay, so you already know some of the surface area of this shape. It's two circles, so pi r squared twice. So you write 2 pi r squared, and then you have to work out the area of this rectangle. Now you know this rectangle is like a wrapper, like a can wrapper. So it has to wrap around the circle. So this circle has circumference or perimeter 2 pi r. That's how far it is all the way around a circle given the radius r. So this is 2 pi r as well, because this has to wrap around that. And we know it's h deep. This width is equal to this, yeah. So basically, it's h times 2 pi r. So 2 pi r h is the area of that. That's pi r squared. That's pi r squared. So you've got 2 pi r squared plus 2 pi r h, and that is the surface area of a cylinder. Okay, and you have to know that. You won't be told that. Okay, let's move off prisms. We've done prisms. So prisms, generally, you work out the cross-sectional area and times by how deep it is. That's how easy work out the area, volume of a prism is. Let's do cones. Cones are like a hat. You know, one of those paper hats, and which hat, or whatever. Basically one of those hats you can wear. Okay, now to work out the volume of a cone, that's very easy, because they tell you the formula for a volume of a cone, which is 1/3 pi r squared h. But generally you should know the volume of any pyramid is 1/3 times the area of the base times the height. So 1/3, so if the base is a circle in this case, so it's pi r squared for a cone. That's the base covered, and then you do 1/3 times pi r squared, and then times the vertical, or they could say perpendicular height from the base, yeah, to the base is anyway. So that's h. L is actually the slanted height. It's the height starting from the edge on one side of the base to the top of the cone. Okay, so any pyramid works like that, and a cone is a type of pyramid. Okay, circular base pyramid. Now that's how you work out the volume, simply 1/3 pi r squared h. How do you work out the surface area? Well, there's two parts. There's a curvy bit, okay, and then there's the base, which is simply a circle. So the curved surface area, okay, is pi r l. That's a formula you're given in the formula book. It's fairly easy to work out, but it takes a long time to explain. Maybe you can leave that as an exercise for yourself to work out how you got pi r l. But I'll tell you very roughly, okay, if you want to work out the area of this, which is pi r l, you have to work out the length of this arc. Okay, and the length of this arc, how can you work it out, is the distance all the way around, because when I wrap this up, it turns into this top thing. Okay, so this meets this, and this bottom bit becomes a circle, which is 2 pi r, as it says 2 pi r there. So this is 2 pi r, okay, and so that length is 2 pi r. Oh my god, I'm not going to explain too much of it. And you can work out the circumference of this entire circle, which this is a piece of, which is basically, he's got length there, so the circumference of the entire thing is 2 pi l. So 2 pi r over 2 pi l is the fraction of the entire circle, and then you work out the area of the entire circle, which is pi l squared times that fraction. That gives the area, which simplifies to basically pi r l. And then you add what they tell you in the formula book is the area of the curved surface area, so that's pi r l. And if you want to work out the total surface area, if it's got a solid base, you simply add the base, which is a circle, which is simply pi r squared. So that's cones done, and explained to a lot of detail. Now, when it comes to spheres, you just have to memorize. Well, you're just told anyway, so there's nothing to learn really. Volume is 4/3 pi r cubed of the ball-shaped sphere, so all spheres are basically ball-shaped, and the surface area, the area of the whole of the top, is simply 4 pi r squared. That's given in the formula book. When it gets interesting is when you've got a hemisphere, well, when you have to think a tiny bit. Hemisphere is simply half a ball shape. What's the volume of half a ball shape? Well, if a whole ball is 4/3 pi r squared, a half a ball is 2/3 pi r squared. So instead of 4/3, it's 2/3, which is half, yeah, of 4. Surface area, not that complicated. Basically, it's half of 4 pi r squared, because it's half as half a board, so the curved bit is basically 2 pi r squared plus the area of the base, which is going to be part of the hemisphere. So pi r squared plus 2 pi r squared is 3 pi r squared, and your job is done.